Good morning to everybody. I would like to start with a small picture of all of you. So if you want to do a crazy thing for me, don't hesitate. Let's go. 1, 2, 3, go. Thank you. Okay. So let's go with that. Who in the room made a decision yesterday? Quite everybody. Who made a decision today, this morning, before coming? Yeah. I can tell you that as a founder, owner, and CEO of a company of 100 millions with employing 850 people, I have to make decisions every 10 minutes or 15 minutes. I was playing on my cell phone during the speeches. I was not on TikTok, I was not on Tinder, I was not on Facebook. I was taking decisions. We all take decisions every day, every hour, every minute. And that's why we are paid. We are paid to make decisions. There is two ways to make a decision, based on facts or based on feeling. And don't under-evaluate the feeling, because the feeling is the sensation you have when your brain has analyzed facts, even without you know it. Facts are based on data. That's important. And for me, that's why and where AI is important. We need to make decisions. We need to make decisions more often than ever in the past. We need to make decisions faster than ever in the past. And we have more data than ever in the past. So it means today we have more data than the capacity of our brain to analyze these data. And that's for me the role of AI. The role of AI is to transform data into informations in order to give you this information to make the right decision. That's why AI is important, okay? That's why it's key today. It's because of the volume of data available, okay? If you were driven a car 30 or 40 years ago, I'm an addict of classic car. When I drive a classic car, I think the only data I got on my dashboard is the speed of the car. Today, if you drive your car, even the most basic car on the market, you have at least 20 data available to decide how to drive your car. And that's the same for any plant. It started with automation. Now you have more and more data available for maintenance, for reliability, and so on. And that's why I believe AI is key in the future. It's to organize all these data into information to help you making the right decision. That's it. The target of my presentation today is to explain the difference between what I call condition monitoring and predictive maintenance. First, it's a difference about approach, okay? Condition monitoring is real-time, knowing the condition of an asset in real-time condition, when the predictive maintenance is predicting when the asset will fail in the future. That's the first thing, question of philosophy. Then, it's about the data. Condition-based monitoring, condition monitoring, is based on threshold, on data, on the state of the asset today, when predictive maintenance is based on advanced analytics in order to predict when the asset will fail in the future. And that's the same about the timing. The target of predictive maintenance is to solve the problem before it arises. That's very important. That's the PF curve. Who knows about the PF curve? Sorry to say, but for me, this is bullshit. Thank you, I'm not alone. Why is it bullshit? You had yesterday Ron Moore here saying that 80 to 90% of the curve, the patterns of failure of an asset are random. It means the PF curve only applies to 10 to 20% of your asset. So if you base your condition monitoring program or your predictive maintenance program on a PF curve, it means if you are the most successful of the world, you will only be successful on 10 to 20% of the asset because the other are failing randomly. What does it mean? It means the only way to monitor and to predict a random failure is to monitor it continuously. There is no other way. If you monitor periodically, you have no statistical chance to detect a random failure. That's statistic, that's physical. It's not me, it's not because it's I care or somebody else, that's just statistical and physical. That's important to know. And why is it changing today? Why are the data available? That's very simple. When I started to work as a PDM engineer 25 years ago, online was very expensive. We were talking about several thousand USD per measurement point. So it was impossible to have online implementation, continuous monitoring of assets in a plant. Only the most critical assets were eligible to get monitored online, to have continuous monitoring. Today, thanks to technology, thanks also to the volume, to give you an idea of the volume, it's a bit like the EV cars. That's a bit like Tesla. The more you produce EV car, the cheaper are the EV cars. That's the same for the online wireless monitoring. To give you an idea, at iCare, we launched our first generation of sensor in 2013. And we have manufactured 1,000 sensors a year for 8 years, 1,000 a year. We launched our second generation of sensor in 2022. And we have manufactured 10,000 sensors until March 2024. And this year, between March 2024 and today, we have manufactured 100,000 sensors. It gives you the effect of the market. The market is growing. More and more people are equipping assets with sensor. It gives you the size effect of the market. And that size effect has an effect on the price. So it's cheaper today than ever to have continuous monitoring of assets. So this continuous monitoring of assets is not limited anymore to the high criticality asset. Any asset can benefit of this continuous monitoring. So you don't have to ask yourself the question if the periodic measurement is fitting the PF curve, which is in fact random. Okay, so now that I hope you are convinced to use continuous monitoring instead of periodic measurement, what are the 3 key points to differentiate condition monitoring and predictive maintenance? That's very simple. The first one is the amplitude, the second one is the frequency, and the third one is the sampling rate. And I will now go more in details in these 3 points. About the frequency, that's quite simple. The higher you go in frequency, the sooner you detect a fault. What is very important to know is the small red box on the bottom left side of the slide. This is the ISO specification. A lot of people refer to this ISO specification, ISO norm. A lot of manufacturers refer to that ISO norm. That ISO norm is nothing compared to today's capabilities of any system on the market. Okay, so it shows how this ISO norm is old-fashioned and how there is a way better instrument today on the market to follow the health and to predict the future health of your asset. Okay, so you have that range of frequency, and I receive often the question, Is it better to use vibration or ultrasound? It depends. It depends on the frequency. Everything is a matter of frequency. Vibration, classically, when I started to work 25 years ago, it was a spectrum of vibration as a maximum frequency between 800 and 1,000 hertz. Few years ago, and still today, a lot of devices have a limit at 5,000 hertz, which is already a lot more than 25 years ago. But these 5,000 hertz are still nothing compared to ultrasound, which are typically around 30,000 hertz. That's the definition of the ultrasound. And above all, you have today capabilities of sensor manufacturer, of system manufacturer, going up to 100,000 hertz. So 100 times more than 25 years ago, 20 times more than today's standard, 3 times more than ultrasound. And just remember that. The higher you go in frequency, the sooner you will detect a failure, you will predict a failure on your asset. And I will conclude with the same kind of slide in a few minutes. The second point, which is very important, is the relationship between the frequency range and the amplitude. If you look at the spectrum, bullshit in, bullshit out. It means that you can get the best AI, you can get the best analyst, you can get the best everything. If your sensor is not measuring the right thing, if the sensor is not processing the data at the right frequency, you will see nothing, okay? That's the difference on the top with a frequency of acquisition of 5,000 hertz, and on below, it's a frequency of acquisition of 100,000 hertz. And you see the difference. That's very simple. If you sample at a too low frequency, you miss the problem. The problems are not there. They are not measured. So it does not participate to your amplitude. It does not participate to ring any bell or to predict anything. That's about the sampling rate. That's very simple. What's the sampling rate? A frequency is how often a phenomenon repeats itself. That's college, okay? That's the opposite of the period. The period is the time between two identical events. So if you want to monitor a frequency, you have to catch at least two identical events. So your sampling rate must be higher than 2 times the frequency you have to catch. That's as simple as it is. So if you want a frequency of 100,000 hertz in your spectrum, you need to sample your data at a rate which is at least 2 times bigger than this 100,000 hertz frequency. That's physics. That's simple. That's basics. If you don't sample at more than 2 times the frequency, you don't see the frequency you are looking for. So these are the 3 dimensions. Now, we talk about wireless online. Why do we talk about wireless online? That's very simple. Do I especially like wireless? No. Do we manufacture wireless sensor? Yes. Because today, this is the cheapest and the easiest way to continuously monitor assets. And I strongly believe that the continuous monitoring is the key and is the only way for the future. So the wireless today is the cheapest way to monitor less critical assets than wired in the past. So that's an additional. If you go wireless, it means you have no power. If you have no power, it means you need a battery. So that's an additional differentiator, more than the pure physical, more than the pure technical thing. You need a battery. And that's also a key factor you have to care about when choosing a sensor. That's the battery life of your sensor. Because if you pay mechanics or electrical people to maintain your sensor instead of maintaining your asset, you don't save money. You don't increase the reliability. You don't face the lack of talent or the lack of number of people, of resource available for maintenance. So that's also a key point to be taken into consideration. And this is, for me, the most important slide. Today, at iCare, we monitor 545,000 assets around the world, from Australia to Brazil, with, of course, the strongest presence in Europe and in the US. And it gives us a lot of information, a lot of statistics, a lot of data to take the right decision, to make the right decision, and to help you making the right decision. What does it mean? It means that today, out of these 545,000 assets under monitoring, the main cause of failure are bearing. Bearing in a race and bearing out a race. And if I go back to the previous slide, the bearing are the problem you can detect with higher frequency monitoring. So if you have a too low frequency monitoring, you will never detect, 25% of the problems. That's key. Then the second root cause of failure is lubrication. As stupid as it is, 21st century, 2024, and we still have 20% of the asset failing because a lack of too much of lubricant. A few years ago, in IMC, we had supplier for RCL, reliability-centered lubrication. Today, we have not a single one. This means we don't care about lubrication, despite a fourth of our asset fails because of wrong lubrication. The third point is looseness. The fourth one is gear problem, imbalance, and then gear problem. And for looseness and imbalance, and also structural, which is a bit later, you see that there is a lot of new technology existing to make it visible, like RDI show just here before. But it's also limited to a few problems. You cannot detect all the problems. You cannot make all these problems visible with this technology. So that's important to have the big picture. Some example, and as I have 10 seconds remaining, I just remind you that frequency, amplitude, and sampling rate, plus the battery life, are the key factors you have to take into consideration when you are choosing about predictive maintenance system. Thank you.